We are going to take you through the ES1000H/1000D control board, the terminals, and the operation. We're going to start at the left-hand side of the board, powering. The ES1000D/1000H control board is only powered through a 12-volt battery. The 12-volt battery is maintained either by solar panel or by trickle charger. However, the charge controllers never run through the control board of the gate opener. The charging the battery is a separate operation. The only thing that gets connected to the control board is the battery itself. We're going to go ahead and connect the battery. Note it gives an audible beep when power is applied. Now we're going to go through the terminals on the bottom of the board. These two terminals are a flashing lamp output. The lamp output is only active while the gate is in motion. This serves as a caution for people that are in the area surrounding the gate. The next two terminals are for motor 1. If you only have a single gate opener, an E-S1000H, these are your two power wires from your motor. If you have a dual gate opener, this is where your primary operator will attach to. Your primary operator is the one that will open first and close second. Note, I have two wires connected. This is for a single gate operation. It is the large red and large black. Please refer to your manual for the order of red or black, as it will change depending on push to open or pull to open. These two terminals are motor 2. Motor 2 is only used in a dual application with an ES1000D. These serve the same purpose as motor 1, just for the secondary operator arm. The two power wires from the secondary operator arm get attached to motor 2. Your secondary operator arm will always open second and close first. You must ensure that your secondary operator arm gets closed first. This terminal block has 3 terminals on it. It is referred to as limit 1. Limit 1 is paired in conjunction to motor 1. These are the limit switches for your primary motor. Here I have wires hooked up from the primary motor in the order of pull to open. Please refer to your manual for an alternate wiring for push to open. I'm going to remove this terminal block so you can see the labeling underneath. Note there's OL1, COM1, and CL1. That stands for open limit, COM, and closed limit. Both limit switches inside the arm, the open and the closed limit, share a COM. These terminals are a normally closed connection. If you do not have limits hooked up to these terminals, the operator will not move. This terminal block is limit 2. This serves as the input for the limit switches from your secondary motor. Your secondary motor is wired into motor 2. If you trace the leads that are going to be hooked up to this terminal, they should pair up with the two power leads that are leading from your secondary motor to motor 2 terminal. This has the same configuration as the limit 1. However, you will notice it says OL2, COM2, and CL2. Stands for open limit switch 2, common 2, and closed limit switch 2. If you have an ES1000H, limit 2 will not be used. For an ES1000D, You will use limit switches in limit 2, or else the second operator arm will not operate. This next terminal block is photocell. You might notice we have an exaggerated jumper in here. This is for demonstration purposes. You can make this much smaller. This is your safety terminal. Notice, if we take the safety terminal off, a pH comes up on the display. This stands for photocell. On the photocell terminal, we have the terminal photo, ground, V positive, and positive 12 volt. Photo and ground are very important. These are the two terminals that we have the jumper in. If you are not using a safety device, which we do always recommend to be used, you need to install a safety jumper where the safety device would be. Once the two terminals are connected either through a safety device or through a jumper, you'll notice photocell goes away off the display and the gate can now be operational again. If you have a safety device connected and you see pH, it is either the photocell is obstructed and something is in the path of the gate, or the wiring has become disrupted between the photocell and the control board. The V positive terminal is a power output meant for one accessory. It is not a fuse terminal, so do not hook up multiple accessories to that terminal. It puts out 12 volts DC. The fourth terminal, positive 12 volt, is also a power output for accessories. However, this is a fused output. This one is safe to hook up the remaining accessories to that you need to get power. This terminal is your push block. Note the terminals are push 1, COM, and push 2. This terminal block is used for devices such as keypads, exit sensors, push buttons, or any other device that is going to open your gate. All these devices will either be connected to push 1 or push 2. All accessories will utilize the COM as a second terminal. Accessories being hooked up to this terminal should be dry contacts. The dry contacts will momentarily close the circuit and cause the gate to open. Push 1 and common will open the gate and close the gate. It will stop the gate mid-cycle. Push 2 and common will only open the gate. If the gate is already in motion going towards the open position, a momentary contact between push 2 and common will not affect the gate. It will continue to open. If the gate is in the open position and there is a momentary contact between push 2 and common, the auto reclose time, if you have it set to auto reclose, will reset. If the gate is closing and there's a contact between push 2 and common, the gate will go to the full open position again. These two terminals can also be used with a non-momentary contact, also referred to as a toggled contact. If you use a toggled contact between push 2 and common, it will trigger the gate to open, and as long as the terminal is toggled connected between push 2 and common, the gate will open and remain open until the circuit is reopened. The last terminal is your E-lock. Has a positive and negative. If you have a solenoid gate lock, these are the two terminals that the solenoid gate lock will receive its power from. You do not need to use a lock control board or any other device when using a gate lock with the ES1000D or 1000H. A magnetic gate lock, however, because it draws power all the time, must be used with an independent transformer. Please contact gate crafters for information about magnetic gate locks. However, the solenoid gate locks are the ones specifically designed to be used with this type of gate opener. In the center of the board, you may notice a red dip switch block with white dip switches. The first dip switch, number 1, is for auto reclose. The gate, when reaching the open position, can either stay open, like a garage door opener, or it can be set up on a timer to close automatically after a certain number of seconds. If you wish for it to be set up on auto reclose, turn the number 1 dip switch up for on. When the gate is in the open position, you will notice AU on the display. This is the countdown for automatic reclose. As long as you see AU on the display, the gate should be counting down for automatic reclose. If the dip switch is down, automatic reclose is off and the gate will stay open for a period of time until you press a remote or another device that's hooked up to push 1. Dip switch number 2 is for single or dual gate. The off position is for a single gate. The on position is for a dual gate. If you have number 2 in the on position, you should have a secondary motor that has the power wires connected to motor 2 and the limit wires connected to limit 2. In this case, we do not. We're going to leave this on single motor. Dip switch number 3 is the output for the E-lock, this terminal. If dip switch 3 is in the off position, no power will be sent to E-lock at the beginning of the cycle. If dip switch 3 is up, this terminal will receive 12 volt power for the duration set in the parameters. In the center of the board, you will notice 3 buttons. These buttons are labeled Set, Button 1, and Button 2. If you press Set, this is how you enter the parameter mode. The first one that comes up is P1, standing for parameter 1. This is the gate opener runtime. The gate opener will run for whatever period of time you set in the runtime, if not stopped by the limit switches. If you press the Set button, you enter the parameter mode. It starts with parameter 1. Parameter 1 is your runtime. The runtime is solely in existence to have a slowdown time, which we'll discuss on parameter 2. When you decide how long it takes to get from open to close for your gate, this is determined after you set up your limit switches and you time it. The runtime should be set 5 to 10 seconds longer than this time. You do not want your gate to stop on runtime. It should always run from limit switch to limit switch. To change this parameter or see what it is set to, you can press button 1 or button 2. Button 1 will increase the value of this parameter. Button 2 will decrease the value of this parameter. Please note, if you set parameter 1 to 20 and you exit the parameter setting and you re-enter the parameter setting, in order to view that 20, you will have to press button 1 or button 2 when you see P1 on display. This will change the value. It will have the effect of seeing 21 instead of 20. When you've decided a parameter is correct, you can press the Set button to move to the next parameter. Parameter 2. Parameter 2 is your slowdown time. This is the number of seconds that are going to pass before the gate goes into half speed. This gate opener is designed to gradually meet the endpoint of where the gate is in the open and closed position. Press button 1 or button 2 to view and change the parameter. Here we have it set for 10. This means the operator arm will get 10 seconds of full power before it starts going into half mode. In half mode, it will move approximately a half the speed that it was moving previously. Typically, you do this for the last quarter of the cycle. We press set again, and now we are viewing P3. P3 is a very important setting. It is your force setting. The higher the force number, the less it will take to make your gate obstruct. The lower the force setting, the easier it will be for your gate to obstruct. You can have this too low, where the gate itself can make the operator arm obstruct simply because of the force the gate has on the operator arm. So there might not be an obstacle in the way, but it acts as if it has hit something. When the gate opener obstructs, what you'll witness is the gate will stop, reverse directions for 3 seconds, and then stop again. If you see that happening, you always know it is an obstruction and not another device stopping it from moving. You should then go to your P3 parameter 3 setting and adjust your force setting. The ideal force setting is a setting that even on days with inclement weather, your gate can get open and closed without obstructing on its own, yet still remain safe for people and cars around the gate. We press the set button again, and now you will see P4. P4 is the delay between leafs. If you have a single gate, this parameter does not apply as you only have one leaf. If you have a dual gate, this is the amount of time that will elapse before the secondary operator starts moving. We're going to press the button 1 or button 2 to make it go up and down. Press the set button to go to the next parameter. Parameter 5, P5. This parameter is the output time to the lock. As we noted earlier, this dip switch controls whether the lock has an output at all. In order for the lock to have an output, this dip switch number 3 must be up in the on position. Once it is up in the on position, the number you set on P5 is how long power will come out of these terminals to the gate lock. If you press button 1, you'll notice we have the options 1, 2, 3, or 4 seconds. Press the set button again to get to P6. P6 is the amount of time before the gate will automatically reclose. If you remember, dip switch 1 is for automatic reclose. Dip switch 1 must be in the up or on position in order for the number of P6 to have an effect on the gate. If you are using automatic reclose, you can press button 1 or button 2 and make the automatic reclose go up or down. These are the number of seconds it will take from the time the gate reaches the open limit switch to the time that the gate starts automatically reclosing. For example, we have it set to 16. Once the gate reaches full open and 16 seconds has elapsed, the gate will automatically reclose and return to the closed position. We press set again. We are now exiting the programming mode. Please note, when in programming mode, you do not have to look at each parameter setting. You can skip to whatever parameter setting you are trying to adjust. This is by pressing the set button. Once you see the parameter you want to adjust, you can press button 1 or button 2 to make the adjustment. When not in programming mode, button 1 and button 2 have an alternate purpose. Button 1 acts the same as any device that is hooked up to push 1 and common. By pressing button 1, it is a momentary contact that will send the gate to open or the gate to close depending on its position. Button 2 acts the same as any device that is hooked up to push 2 and common. By pressing button 2, it will send the gate to open, it will not send the gate to close, and it will reopen the gate during a closing cycle. On the far right of the control board, you will notice 5 prongs. These 5 prongs are where the receiver hooks up to. This is the connector for the receiver. It plugs in with the red on the bottom. Please note, the other end of the wire should be already connected to the receiver. If it is not already connected to the receiver, you run the risk of shorting the wires that lead to the receiver and damaging your control board. On the left-hand side of the control board, you will find 3 fuse boxes. The fuse boxes are hinged on the top and open from the bottom. Insert the screwdriver and it pops open. The first fuse is the protected output for the positive 12 volt accessory. This is your power for the 12 volt accessory. The second fuse is for your motor 2. If you ever experience your motor 2 stops running, yet your motor 1 is still running, check the center fuse. The third fuse is for motor 1. If you ever find that motor 2 is running and motor 1 is not, check the third fuse. One diagnostic I wanted to share is if the board shows LU on the display. LU stands for low voltage. We intentionally pulled a battery that has been drained. This battery has 12.1 volts in it. The cutout is 12.5. A fully charged battery should be around 13.8. This battery has too low a voltage. The stress it would cause the system by running off this battery could damage circuits, so the board will shut down and show LU on the display until you get a fully charged battery.